Hi, this is the video for Expo Lesson 10.0a. We are going to be simplifying numerical radical expressions. This time there's going to be some fractions in there, and we're going to talk about something called rationalizing the denominator. So let's go ahead and get ourselves started here. Just as you're able to split up square roots, you can turn square root of AB into square root of A times square root of B. You're able to split those up. You're able to do the exact same thing with fractions. So if it has square root of A over B, you can write that as square root of A over square root of B. So you're able to split those up. It's nice when things are a perfect square. I don't know why I'm scribbling right there. When you have a perfect square for each, the numerator and the denominator, it works out pretty nicely. We have square root of 4 over square root of 9, and the square root of 4 is 2. And the square root of 9 is 3, and that is simplified as much as we can go. Okay, this one doesn't have a perfect square in the numerator, but it does in the denominator, so this is still okay. We have square root of 3 up top. We have square root of 25 on the bottom. The square root of 25 is 5. The square root of 3 is going to be as simplified as we can make it because there's no perfect squares that go into 3. So we just leave our answer as square root of 3 on the top and 5 on the bottom. Okay. Reducing. Okay. When can you reduce? Okay. The first two situations are times where you can reduce. Okay. You can when both numbers are outside of the square root. Okay. So in this situation, 2 and 4 are both outside of a square root. So I am able to reduce that. 2 goes into 4 twice. Okay. So you can write that as 1 square root of 3 over 2, or you could just write it as square root of 3 over 2. So that's okay if they're both outside the square root. Okay. Or when both numbers are inside the square root. Okay, you're able to reduce. So since 2 and 8 are both under the square root, I'm able to reduce inside the square root. So 2 and 8 reduce to 1 and 4, and then I'm able to write that as square root of 1 over square root of 4, but that's just 1 over 2. Okay. But this is the situation that you are not able to reduce. Okay? So this does not equal square root of 1 over 2. Okay? Since one of these was under a square root and one of them was not, I cannot reduce those if you have one of each. Okay? So the time that it's a no is when you have one under square root and one not. Okay, so if you have one that's in a square root, one that's not, you are not allowed to reduce those numbers. Okay, and then the last bit on this page of the notes, always reduce first if possible. So here's why I would talk about that right here. You could go to splitting this up, but neither square root of 8 nor square root of 50 are perfect squares. But if you look to reduce this further, there's nothing wrong with taking that step. Then we would have to reduce square root of 8 and square root of 50 by taking out perfect squares. Okay? Or we could say, well, let's just reduce 8 over 50. And if we do that, something really nice happens. Okay? If we divide them both by 2, we get the square root of 4 over 25, which is the square root of 4 over the square root of 25, which is 2 over 5. We could have gotten the same answer starting with the square root of 8 and 50 and reducing those, taking out perfect squares. We would have eventually gotten down to 2 over 5. This one says simplify first if possible. This you cannot write as 1 over square root of 18. Okay, you can't divide them both by 2 because one of them is under a square root and one of them is not. But we have a square root of 36 on the bottom, which is 6. Okay? And then we just take one step to reduce that fraction right down. All right, so then the next topic is about something called rationalizing the denominator. So historically in math, it was not proper to divide by a radical. I think before calculators and stuff, it wasn't very easy or convenient to divide by square root of 2. So there was a process of eliminating the square root on the bottom, and it is called rationalizing. And this is a skill that you will need moving forward. We do it a lot in geometry, and you'll certainly look at it again in Algebra 2. How do we rationalize? Okay. Well, first we simplify as much as we can. So this means reduce, okay, and reduce fraction, okay, and simplify, okay, or evaluate all square roots, okay, and then maybe reduce again at the end. All right, so then what happens is you end up with, maybe we have something like this. We're not allowed to have a square root on the bottom. So this right here would be an issue. We would not be able to leave our answer like this. So what we would do is we would multiply the top and the bottom by the root on the denominator, or in the denominator is a better way to say that, okay? So what happens is we would multiply this by the square root of 3 over the square root of 3, okay? And why would we do that? Well, look what happens, okay? What happens here is we get on the top, we get 2 times square root of 3. On the bottom, we get the square root of 3 times the square root of 3. And if you multiply a square root by itself, it's going to cancel. This is like the square root of 3 times 3, which is 9. Well, that's just 3 on the bottom. Now there's no root on the bottom. There was before, and now there's not. Okay? So that's how you rationalize a denominator. Remember, just real quickly from last week, the square root of x squared is x. Okay, and then again, simplify at the end. Okay? All right, let's try a couple. Oh, I had square root of 3 on here anyway, so that's okay. We're going to simplify the roots of the fractions before you start and when you're done. So, I have a 1 over square root of 3. I'm not able to simplify the square root of 3 at all because it is as reduced as it can possibly be already. There's no perfect squares that go into 3. So, what we're going to do is we're going to move this square root up. Right now, this is a problem. I'm not allowed to leave the answer like this because it's a square root in the denominator. So what we do is we multiply the top and the bottom by that square root that's on the bottom. And what that does for us is now we have 1 times square root of 3, which is just square root of 3 up top. On the bottom, we have square root of 3 times square root of 3. And if you multiply a square root by itself, it's going to cancel. You get square root of 9, which is just 3. So square root of 3 times square root of 3, that's kind of like this, square root of 3 squared. And if you square a square root, okay, or if you take square root of something squared, you get x. So you get that to cancel out. All right, so this would be our answer because 3 and 3, even though we could divide 3 by 3, one of them is under a square root, one of them is not. Same thing here. 2 and 5, 2 over square root of 5, nothing to reduce here, but we can multiply top and bottom. We need to multiply top and bottom by the square root of 5. It's essentially moving the square root of 5 to the top, and it's canceling the square root on the bottom. The square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 is 5. And this will work every time for us. Okay? These ones we just need to reduce first. So let's try these last couple. This can reduce down, and we could do this a couple different ways, but let's do it where we reduce the fraction. So this is square root of 2/3. And then we can say, well, that's the square root of 2 over the square root of 3, okay? Which is fine, but we can't have a square root of 3 on the bottom as an answer. So we can multiply the top and the bottom by the square root of 3. Okay, and what happens next is we have square root of 2 times square root of 3 up top. We have just a square root of 3 times square root of 3 on the bottom, just made 3. What we are allowed to do, since these two are both under a square root, what we're allowed to do next is we are able to multiply, ignore the bell going off, we're able to multiply the square root of 2 times square root of 3 and make that square root of 6. On the top, then we have square root of 6. On the bottom, we have 3. And this is our answer. We are not allowed to reduce the 6 and the 3. One of them is under a square root, one of them is not. All right, again, let's reduce everything we can for this last one. 8 and 2, these are already outside of square root, so I'm going to reduce that right away. So I'm just going to take one step to write that as 4 and 1, and then we have square root of 45. Square root of 45 is not reduced fully, which means we can take a square root, a perfect square, out of that 45. So I'm going to write my 4 again up top. Okay. I'm going to not write the 1 on the bottom anymore, but the square root of 45 could be written as square root of 9 times the square root of 5. Okay. And we know that we have the square root of 9 is 3. So we have 4 over 3 times the square root of 5. Okay. And we are almost done. That's most of the work. We just have to move the square root of 5 to the top. Okay. And the way that we do that is by rationalizing. So we're going to multiply, sorry, I'm a little bit out of space, but we're going to multiply square root of 5 over square root of 5 so that we can cancel out these ones right here. So what we're left with next, we have 4 times the square root of 5 up top, and those cannot combine because one of them is under a square root. On the bottom, I have a 3, okay? And then this square root of 5 times square root of 5 made just a regular 5. That's the square root of 5, or the square root of 25, which is 5. Okay, one last step to write the answer then. Let's write it down here. We have 4 square root of 5 on the top. On the bottom, we have 3 times 5, which we can just write as 15. So this takes a little bit of practice, but that's called rationalizing. That's something that you're definitely going to need to be able to do. So thanks for watching. Try to practice and talk to your teacher about whatever questions that come up.